Thakur Vidya Mandir High School and Junior College welcomes all the 12th standard computer science students. Today we are going to learn with the next part of Unit 1, that is. So before going ahead with the concept of registers, let us brush up the previous topic that we have done. The previous class we have learned how to demultiplex address and data bus using ALE. Secondly, we have learned microprocessor based system where we learned about the input device, the output device, the memory, the control unit and the ALU. So today let us discuss about the registers. So before going ahead with the today concept, there are small block diagrams which are going to relate to the concept. It is totally different from the block diagram of your microprocessor. Depending upon the concept, we have small block diagrams. So first, let us understand the concept of registers. First, the data from the real world goes to the input. From the input, it goes to the memory, which is outside the microprocessor. From the memory, it goes inside the microprocessor, that is to the registers. From the registers, it goes to the ALU. It performs arithmetic and the logical operation. The control unit will be controlling all the process. From the arithmetic and the logical unit, after processing, it goes back to the registers, then to the memory, and finally it comes to the output. So your data, when you're gathering, it goes to the input memory. From the input, from the memory, it goes to the registers inside the CPU. From the register, it goes to the ALU, performs all the arithmetic and the logical operation. From the ALU, it goes back again to the register, then to the memory, and finally at the output. Registers. So before going ahead with the concept of registers and its types, let us understand what is a register. Register in 8085. In general, registers are made up of flip-flop. Flip-flop is an electronic circuit which stores one bit data. A group of flip-flop together form your registers. So we know what is a flip-flop. Its other name is latch. It is an electronic circuit which stores one bit data. So depending upon the bit of registers, we group up the flip-flop. For example, if I want 4-bit register, I take 4 flip-flop. But here, according to the word length of 8085 microprocessor, the registers are of 8-bit. The registers are of 8-bit. So 8 flip-flop together form your 1 registers. So registers in 8085 is classified into 2 groups. The first group is the general purpose register. The second group is the special purpose register. So again I am repeating the concept. Registers in 8085 is classified into 2 groups. Registers are made up of flip-flop. Flip-flop is an electronic circuit which stores 1 bit data. Registers are classified into 2 groups, general purpose register and special purpose register. So first let us understand general register. So this is the diagram of register with my purse where we have accumulator flags B, C, D, E, H, L, program counter, stack pointer, address and the data bus. So we are going to learn all the register, but here address and the data bus we have already discussed in our previous class. Let us understand general purpose register. There are 6 general purpose registers in 8085 which is used to store 8-bit data during the program execution. So whenever we want to work with my 8-bit data, we pick up the 6 general purpose registers. They are B, C, D, E, H and L. Each is of 8-bit. They are B, C, D, E, H and L. Each is of 8-bit. So these are my 6 general purpose register. Keep in mind students, the registers plays a very important role in your programming part. If you are not understanding the registers, you won't be able to understand the programming part. So B, C, D, E, H, L each is of 8-bit. Now if I want to access my 16-bit address or else if I want to store a 16-bit data, this 8-bit register is not at all sufficient. So we combine these registers to form register pair which is used to perform 16-bit operation. So again I am repeating, we are going to combine the registers to form register pair to perform 16-bit operation. So we combine B and C register together to form BC. So B is 8-bit, C is 8-bit. They together form your 16-bit BC register pair. They form together 16-bit BC register pair, where C or will be the lower order register and B will be the higher order register. Similarly, we combine D, the higher order register, with E, the lower order register. Each is of 8-bit to form 16-bit register pair, that is DE. Similarly, we will go with H, which is the higher order register, L, which is the lower order register. We combine together this register to form HL register pair, which is 16-bit. So we have here 6 general purpose register B, C, D, E, H and L to perform 8-bit operation. In order to perform 16-bit operation, we pair up the registers as BC, DE and HL. Keep in mind the pairing cannot be changed. It will be as it is. Okay, here some of the register pair which is of 16-bit is also called as the memory pointer. H will be called as the memory pointer, which is represented by M. HL register pair is also called as the memory pointer, which is represented by the alphabet M. So we have learned here B, C, D, E, H and L. Your 6 general purpose register. The register pair are BC, DE and HL, which is 16-bit. So registers are 8-bit. Register pair is of 16-bit. Here sum of the register pair is also called as the memory pointer, and HL will be the only register pair which is called as the memory pointer, which is represented as M. Let us understand with the special purpose register. The first and the very important special purpose register is the accumulator. It is also identified as register A. It is of 8-bit. So we can also call the accumulator as register A. It is of 8-bit. It acts as a gate for the microprocessor. Simple words. If there is a concert or an event going to take place, we require a gate pass to get inside the event. Similarly, for arithmetic and the logical operation to take place inside the ALU, the gate pass will be your accumulator. Why we take it as a gate pass? By performing any arithmetic or logical operation, one of the operand, simple words, one of the operand. Operand is nothing but a number, is stored in accumulator. And after the operation, the final result is also stored in accumulator. So again, I am repeating the concept. Accumulator is also called as A register. It is 8-bit. It acts as a gate for the microprocessor to perform arithmetic and logical operation inside the ALU. While performing arithmetic and logical operation, one of the operand, that is the number, should be compulsory stored in accumulator. After the operation, the final result is stored in accumulator. For example, let me consider two numbers, 63 plus 33. So the answer is 96. Here I am writing H to represent hexadecimal number. So let me consider 63 is in A register and 33 is in C register. So when I am adding A and C register, which is a general purpose register, the data will be again stored in A. So the initial value of accumulator was 63. After the arithmetic operation, the final value is 96. Okay, here no doesn't mean that we have to take only C. We can take any general purpose register. It can be B, H, L and so on. So here, while performing arithmetic and logical operation, one of the numbers should be stored in accumulator. After the operation, the result will be stored in accumulator. The accumulator can be both a primary source as well as a destination register. In simple words, we can transfer the data from any register to accumulator. So here the accumulator will be forming a destination register. If I want to transfer the data from accumulator to any register, then here A will be your source register. So it can be both a primary source as a destination register for any operation to be performed. All data transfer operation and arithmetic and the logical operation takes place inside the ALU with the help of accumulator. So here the main programmable registers are A, B, C, D, E, H and L. Okay, these are the 7 main programmable registers. So we are going to use up the 7 main programmable register and its register pair to perform your programming part in 8085 microprocessor. Understand the temporary register. There are two temporary registers present in 8085. They are W and Z. The two temporary registers W and Z each is of 8 bit. The main key point of this register is this register is not available to the user. The registers that are available to the user are B, C, D, E, H, L and A. These two registers are not available to the user. These two registers is used by the microprocessor to store any data temporarily. That is why we call it as a temporary register. It's a very important key point, student. Keep in mind it can be asked in your Viva also. Which are the two temporary registers of 8-bit and how much bit it is. Now, let's go back to the ALU. I'm showing you the diagram of ALU where I have already written to be continued and I have already told to leave some space. So you can see here we have learned about accumulator and the temporary register. The accumulator and the temporary register here because already in the we have learned about adder, we have learned about shifter, we have learned about the internal bus, that is the system bus. So these two temporary and the temporary register and the accumulator. So one more point to be added in the ALU. First point is accumulator and the temporary registers are closely associated with the ALU. First thing, accumulator and the temporary registers are closely associated with the ALU. The second part is by performing arithmetic and logical operation, one of the numbers should be stored in accumulator and after the operation, the final result is stored in accumulator. So while performing arithmetic and logical operation, one of the numbers should be stored in accumulator and after the operation, the final result is stored in the accumulator. So these are the three new points that you are going to add in the ALU part. Still in the ALU part, we have left off with the status register that we will learn later on. Okay, now let us understand the next register, which is the instruction register. Instruction register is 8-bit. It stores the first byte of the instruction, that is opcode. What is an opcode? Opcode is a short form of operational code. The other name is called as hex code. Do you remember the output device? There were four 7-segment display for your address and two 7-segment display for your data. So whenever we are going to do any program, the program will be converted into opcode. The opcode sheet will be provided to you. The program will be converted into code and then we enter inside the microprocessor kit. Keep in mind, it's not like the other programs. Normally in C++, when you write any program, you straight away go to the C++, you type the program, you check the output. But here in microprocessor, when you write any program, the program will be converted into hex code and then we are going to enter inside the microprocessor kit. So it is an 8-bit register. The first byte of the instruction, that is opcode, is stored in the instruction register. Let me consider an example. For example, sub A. Sub is nothing, subtraction. A is your A register. The opcode of sub A is 97. The opcode of add M is 86. Now 97 and 86 are the two codes. How will you come to know that this is the opcode of sub A and add M from the opcode sheet that has been provided to you? But how will be the processor coming to know what is 97 and 86? It can be even a data, right? So the processor will come to know via the instruction register. So when the data goes to the instruction register, the instruction register will identify that 97 is equivalent to sub A. So it will perform the operation as per that. We will learn in detail about the opcode and these are simple two instructions that I have given which we will learn in detail. So again I am repeating, instruction register is 8-bit. The first byte of the instruction, that is opcode, is stored in the instruction register. Okay, each and every instruction has its own opcode. Whenever you are writing a program, the program will be converted into its opcode via the sheet that will be provided to you and then it will be entered into the kit. Okay, so the processor will be confused whenever this code is going. So in order to identify what is the instruction equivalent to the code, we use up the instruction register. Next comes the instruction decoder. It interprets the type of instruction. What type of instruction? It is arithmetic, it is logical, whether I have to transfer a data. Second, it determines the exact steps that has to be followed in executing the instruction. So keep in mind the instruction decoder does two functions. First thing, it interprets the type of instruction. What is the instruction, what I have to do. Second, for executing this instruction, what are the exact steps that has to be followed. That will be decided by the instruction decoder, and then it will be given to the timing and the control unit. So the output of the instruction decoder will be directed to the timing and the control unit. Instruction decoder in general is not at all a special function register, but when we speak about instruction register, we have to link instruction decoder in that. That is why I have considered under the special function register instruction decoder. So instruction decoder performs two important functions. First, it interprets the type of instruction. Second, what are the exact steps that has to be followed in executing the entire instruction. And then it gives to the timing and the control unit to give time for the operation to be performed, and that is why we say the output of the instruction decoder is directed to the timing and the control unit. Now let us understand a diagram which is going to link the instruction and the decoder. So from the input it goes to the memory. From the memory, whatever is the opcode will goes to the instruction register where it will identify what is the type of instruction. Second, it goes to the instruction register, from the instruction register to the decoder where it will interpret. The output of the decoder is the timing and the control unit, and then it goes to the registers. So then the registers will be performing any operation. So initially we know input is there, memory is there, and then we have the registers. But in between that we have the instruction register, instruction decoder, timing and control unit. So the instruction register will identify what operation to be performed and it gives to the instruction decoder. Instruction decoder will be interpreting the type of instruction, and what are the exact steps to be followed will be decided by him, and then it will be given to the timing and the control unit. The output of the timing and control unit will be going to the register, that is the CPU. Next, let's speak about program counter. This register is a special function register which comes under the category of 16-bit. Till now, whatever registers we have learned, all are of 8-bit. This register is so special, it comes under the category of 16-bit. So it is a 16-bit register. We can also call it as PC. Okay, it is used by the processor to sequence the execution of the instruction. So whenever there is a program, if you want to execute the program, in order to execute the program in a sequence way, that is the definition of your processor, to execute the program in a sequence way, the program counter plays a very important role. This register will be acting as a pointer during the execution of the program. It always stores the address of the instruction that has to be executed. Then it always keeps the track of which instruction is to be executed, which instruction is being used, and what will be the next instruction. PC gives the address of the memory location from where the instruction is to be fetched. Once the instruction has been executed, the program counter automatically gets incremented by 1 and it points to the next location. So, for example, if I am considering C000 as a memory address, we know that the address is always represented by 4 digits. So, in C000, we have an operation XOR A. It is just an instruction we will learn in detail. Okay, we have an instruction. So what is the initial value of the program counter? It will be C000. It will point to C000 and it will inform the microprocessor to go to this address and perform the operation. So what will the processor do? It will go to C000, whatever is the operation. Here it has been XOR A. It will fetch, it will decode, it will execute, and once the instruction has been executed, the program counter will point to the next address, that is C001, and it informs the processor go to this address and perform the next task. So if here there is MOV B, A, once the processor has fetched, decoded and executed, again the program counter will point to the next address. to the next address. So automatically after the operation has been performed by the processor, automatically the program counter gets incremented by 1 as C00, 1, 2, 3, 4 and so on. It will help the microprocessor to perform the operation in a sequence way till the program ends. For example, in C010, if I'm ending the program, so the last address of the program counter will be C010 where I'm stopping the process. So the last address will be C010 where the program counter is being stopped. So in general, what is the function of the program counter? To guide the microprocessor to perform the entire operation in a sequence way. To guide the microprocessor to perform the entire operation in a sequence way. A simple example let me consider. See, for 12th standard computer science 2, I'm going to guide you. I'm going to guide the concept from the starting to the end, where I'm going to link each and every concept in the sequence way so that there is a relationship between the previous concept and the new concept. So the similar way, I'm going to guide you to learn everything in the sequence way. Similarly, here in your microprocessor, the program counter will be guiding you to perform any operation in a sequence way. So simple words, it is 16-bit. In order to help the microprocessor to execute any program in a sequence way, the program counter plays an important role. Once the operation has been performed, once the instruction is fetched, decoded and executed, automatically it will get incremented by 1. It will point to the next address. Once that operation has been done, it will point to the next address. Automatically it will get incremented by 1 only, and it will guide the microprocessor till your program ends. Okay. So the stack pointer is the next 16-bit register, which is also called as SP. It points to the memory location in the read-write memory. A stack will be having its own memory location in the read-write memory. We can easily access the stack pointer through instructions. It holds a 16-bit address on the top of stack. It is auto incremented and auto decremented during pop and push instruction respectively. These are two instructions that we will learn later on. Okay, when I'm teaching you the concept of push and pop, again I will come across this point. Okay, stack pointer is 16-bit. The stack pointer plays a very important role in the read-write memory. It has its own memory location. So let me give an example of how the stack pointer is being used. This is a simple example to understand. For example, if I'm reading a novel, I'm in my bus, I'm reading a novel. So my stop comes. So what I do, I close the book, and again when I'm opening my novel, I find very difficult to find the page from where I have to start again. I'm not going to start from the beginning. But instead of searching for the pages, if I'm keeping a bookmark where I have ended, so it will be very easy for me to start from where I have stopped. Similarly, when the microprocessor is performing any task, if any disturbance comes, the microprocessor has to stop and it has to give response to the disturbance. So once it completes the disturbance, again it has to come back to the its process. So again when it's coming back to the process, it will be very difficult for the processor to start from beginning. So it will start from where it has stopped. So the address will be temporarily stored here. Simple, keep in mind the stack pointer will be acting as a bookmark register. So today class, we have learned about register and its function, where we have learned about the general purpose register, B, C, D, E, H and L, special purpose register, accumulator, instruction register, temporary register, program counter, stack pointer, instruction decoder, and individually we have learned its function. Okay. In the next class, we have the flag register that we will learn in detail. Okay. Thank you, students.